Now we are going to solve some problems related to venturimeter and orifice meter. Right, these two are the equipments used to measure the flow rate in case of pipes. Right, please note down the first problem. An oil of specific gravity, 0.8 0.8 is flowing through a venturimeter having inlet diameter 20 centimeters. Inlet diameter 20 centimeters and throat diameter 10 centimeters. Throat diameter 10 centimeters. The oil mercury differential manometer shows a reading of 25 centimeters. Calculate the discharge of oil through the horizontal venturimeter. Take CD equal to 0.98. CD equal to 0.98. Right, in this problem, an oil is flowing through the venturimeter. The diameter of the inlet given, throat dia given, and coefficient of discharge also given. Find the rate of flow flowing through the venturimeter. Right? Here, this is the throat, this is inlet, this is the outlet. Convergent zone, throat, and divergent zone. Right? Suppose this is section 1.1, this is section 2.2. We are going to connect the manometer like this. This is the manometer. This is center line of the pipe. Because the cross-sectional area is more here, the cross-sectional area is less here. Because of the more cross-sectional area, the pressure head is more here. So that the mercury level in the manometer is move towards this direction. Right? In this problem, they have given the mercury level difference in the manometer x is equal to 25 centimeters. 25 centimeters. Right? Now we are going to determine the flow rate from the venturimeter. Already I have given one formula, that is discharge through the venturimeter Q equal to CD A1 A2 divided by root A1 square minus A2 square into root 2GH. This is the formula for the determination of discharge from the venturimeter. Right, CD value is given 0.98. A1 value we are going to determine because they have given diameter at the inlet. The inlet diameter is equal to 20 centimeters and throat diameter is equal to 10 centimeters. Based on the 20 centimeters dia, cross-sectional area A1 is equal to pi d1 square by 4. This is equal to pi into d1 is nothing but 20 centimeters. 20 square divided by 4. Therefore, A1 is equal to pi d1 square by 4. Pi into 20 square divided by 4. Therefore, A1 is equal to 314.16 centimeter square. Then we are going to determine A2 cross-sectional area at throat. Cross-sectional area at throat, that is equal to pi d2 square by 4. This is equal to pi into what is d2 diameter at the throat is given, that is equal to 10 centimeters. So 10 square divided by 4. Therefore, cross-sectional area at throat is equal to 78.54 centimeter square, right? CD known to us, A1 is calculated, A2 is calculated, and 2 is the value, and G is nothing but 9.81. Only unknown is H. For the determination of the discharge Q, all parameter known to us, only unknown is H. H is determined by using the given data, that is the level difference between the manometer, the pressure. This is the pressure head here, one pressure head at section 11, another pressure head at section 22, or one pressure head at inlet of the pipe and another pressure head at the throat. The inlet of the pipe, the pressure head is more as compared with the throat pressure head, therefore the mercury is moving towards this side, right? Because of this liquid moving from left to right, there is a level difference, mercury level difference is given, that is 25 centimeters. Based on that, we are going to determine the pressure head difference between two sections. Pressure head difference. Pressure head difference between two sections, H is equal to, already I have given one formula, that is X into specific gravity of the heavy liquid divided by specific gravity of the flowing liquid minus 1. This is the formula I have given, right? X is the manometer reading, that is the level difference between two limbs, and Sm is the specific gravity of the heavy liquid, that is the manometer liquid. S0 is the specific gravity of the flowing liquid. Here the flowing liquid is oil. Oil specific gravity is given, that is equal to 0.8 minus 1. This is equal to, X is nothing but 25 centimeters. Specific gravity of the mercury is 13.6. Specific gravity of the flowing liquid given, that is equal to 0.8 minus 1. Therefore, the pressure head difference between section 11 and section 22, or the pressure head difference between inlet and throat, is equal to 400 centimeters. Right? We have H also. Now we are going to substitute the values in the standard equation. Finally, we have the discharge flowing through the venturimeter. Therefore, Q is equal to, what is the CD value? 0.98 into A1. What is the A1? First you note down formula, A1 A2 divided by square root of A1 square minus A2 square into root 2GH. Right? This is equal to 0.98 into A1 is equal to 314.16 centimeter square, 314.16, A1, A2. A2 is nothing but 78.54, divided by square root of A1, A1 square minus A2 square, A1 square minus A2 square into root 2G 9.81 into what is the H? We have determined here, that is equal to 400. Finally, discharge Q is equal to 70465 centimeter cube per second. Now we are going to solve one more problem related to venturimeter. Please note down the problem. A horizontal venturimeter with inlet diameter 20 centimeters. Inlet diameter 20 centimeters. D1 is equal to 20 centimeters. And throat diameter 10 centimeters. That is D2 equal to 10 centimeters. Is used to measure the flow of oil of specific gravity 0.8. Specific gravity given, that is 0.8. the discharge of oil through the venturimeter is 60 liters per second. In this problem, they have given discharge Q equal to 60 liters per second. First, this convert into centimeter cube per second. 60 into 1000, that is the centimeter cube per second. Right, this is the discharge. Discharge Q is equal to 60 into 1000 centimeter cube per second. Find the reading of the oil mercury. Find the reading of the oil mercury. That means X is equal to what? This is the inlet, this is outlet. The oil is flowing from left to right. Because of the cross-sectional area is more at inlet. Once the cross-sectional area is more as compared, cross-sectional area is more at inlet as compared with the throat. Therefore, the cross-sectional area is more here. Automatically, pressure head is more here as compared with the throat. So that the liquid, the heavy liquid, move towards the right side. As per this given data, we are going to determine what is the level difference between the section or left side and right side, or what is the manometer reading. This is equal to X. Now we are going to determine the X. In this problem, they have given specific gravity of the flowing liquid, diameter at inlet, diameter at throat. CD value is also given in the problem, that is equal to 0.98. CD value is also given, and discharge equal to 60 liters per second, that is equal to 60 into 1000 centimeter cube per second. Right, now we are going to determine the X. As per the given data, the X is involved in head, that is the pressure head difference between the section 1.1 and section 2.2, or the pressure head difference between the inlet and throat. Now we have one standard formula with respect to pressure head, that is Q equal to CD into A1 A2 divided by root A1 square minus A2 square into root 2GH. In this equation, discharge is given, that is equal to 60 into 1000 centimeter cube per second. Area we are going to determine based on the diameter at inlet given, D1 is equal to 20 centimeters. A2 also we are going to determine based on the throat diameter given, that is 10 centimeters. And 2 is known to you, G is also known to us, that is 9.81. And H we are going to determine by using this entire equation. Once we know the H, then we are going to determine the X value. H is equal to X into manometer liquid, that is heavy liquid, divided by flowing liquid. Manometer liquid specific gravity or heavy liquid specific gravity to the flowing liquid specific gravity minus 1. This is the formula. Once we are going to determine the H from this equation, then we are going to determine the X. Right? First, what is area A1 at the inlet? Area at the inlet is equal to same formula. Here also pi into D1 is nothing but 20 centimeters divided by 4. This is equal to 314.16 centimeter square. Right? At throat, cross-sectional area A2 equal to pi D2 square by 4. Pi into D2 is the 10 centimeters. The diameter at the throat is given, that is 10 centimeters. This is equal to 78.54 centimeter square. Now we have determined cross-sectional area at inlet, cross-sectional area at throat, and coefficient of discharge also given in the problem, 0.98. All parameters known to us. Now we are going to determine the H by substituting the known values in the standard equation. Right, Q is equal to 60 into 1000 centimeter cube per second into CD value 0.98 into A1 314.16 A1 into A2. A2 is nothing but 78.54 divided by square root of A1 square 314.16 square minus A2 square 78.54 square into root 2 into G 9.81 into H into H. H is only unknown. All known parameters in this equation, based on the known parameters, we are going to determine the H, that is the pressure head difference between the section 11 and section 22, or the pressure head difference between the inlet and throat, that is equal to H is equal to, from this equation, H is equal to 281.7 centimeters. The pressure head difference between inlet and throat is determined, that is H is equal to 281.7 centimeters. Our aim to determine what is the manometer reading difference. What is the manometer reading difference? That is X. We have one formula, relation between the H and X. H is equal to X into X is the manometer reading, SM is the specific gravity of the heavy liquid, S0 is the specific gravity of the flowing liquid minus 1. Now substitute the values here. H is equal to X SM minus S0 minus 1. Now H is equal to 281.7. X is nothing but unknown. SM is the specific gravity of the mercury, that is 13.6, divided by S0 is the flowing liquid specific gravity, that is given 0.8 minus 1. All parameters are known, only unknown is X. Now we are going to determine the X from this equation. X is equal to 18 centimeters. Right? Earlier problem, we have determined discharge flowing through the pipe. At that case, they have given manometer reading difference. Based on that, we have determined the pressure head difference between the section 11 and section 22. That H is substituted in the main equation. A1, A2 determined by using the diameters given. Based on that, we have determined the discharge. But here in this problem, discharge is given. Based on the discharge, we have determined here, that is the manometer level difference, that is X. Right? Orifice meter and venturimeter both are used to determine the flow rate in case of pipes. Right. Please note down one problem. An orifice meter with orifice diameter 10 centimeters. Orifice diameter 10 centimeter is inserted in a pipe of 20 centimeters diameter. Pipe of 20 centimeter diameter. The pressure gauges fitted upstream and downstream of the orifice meter gives the reading of, that means P1 is equal to 196.2, 19.62 Newton per cm square, and another one is 9.81 Newton per cm square respectively. Coefficient of discharge for the orifice meter is given as 0.6. Coefficient of discharge to the orifice meter is given, that is 0.6. Find the discharge of water through the pipe. Find the discharge of water through the pipe. Q is equal to what? Right? In this problem, they have given orifice meter, orifice dia given, pipe dia given. Right? This is one horizontal pipe. The diameter of the pipe is 20 centimeters. An orifice is provided like this. The orifice dia is 10 centimeters. They have provided gauges, pressure measuring gauges. One is upstream side. This is upstream side of the orifice. This is downstream side of the orifice. Here they have provided one dial gauge, and downstream side also provided one dial gauge. That gauges shows the reading, that is upstream side dial gauge shows the reading P1 is equal to 19.62 Newton per cm square. This is equal to 19.62 Newton per cm square. This is 9.81 Newton per cm square. Now they want to determine the discharge flowing through the pipe. Coefficient of orifice meter is also given, that is 0.6. The discharge formula, Q is equal CD into A1 A2 divided by A1 square minus A2 square root into root 2GH. Now we want to determine the rate of flow Q, but we know the diameter of the pipe and diameter of the orifice. Based on that, we are going to determine the area, that is here not A1, A0 into A2, right, A0 into A2, A1 square minus A0 square. Right, A1 is equal to same formula, pi d square, pi d1 square by 4. This is equal to pi into d is equal 20 centimeters square divided by 4 equal to 314.16 centimeters square. Right? Cross-sectional area of the orifice A0 is equal to pi d0 square divided by 4 pi into diameter of the orifice, that is given 10 centimeters. 10 square divided by 4, this is equal to 78.554 centimeters square. Right? Discharge, coefficient of discharge given. A0, area of the orifice we have determined here. A2, area of the pipe is also determined here. And known to us, G is equal to acceleration due to gravity, that is equal to 981. And only unknown is H. Now we are going to determine the H. Then that value substitute here. Finally we have the rate of flow from the pipe. Right? For the determination of H, or the pressure head difference between pipe and orifice, they have given some data, that is the pressure at the upstream of the pipe, that is given P1 is equal to, this is the value, right? P1 is equal to 19.62 Newton per cm square. First this converts into Newton per meter square, that is equal to 19.62 into 10 power 4 Newton per meter square. Right? Now we are going to determine the pressure head. Pressure head upstream side, or pressure head in the pipe. Okay, this is the pipe dia, this is the orifice dia. The pressure head is more here. Okay, pressure head that is equal to P1 by W or P1 by rho into G. W is nothing but unit weight. Unit weight is also nothing but mass density of the flowing fluid into acceleration due to gravity. Therefore, P1 is equal to 19.62 into 10 power 4 divided by rho value. The flowing liquid is water. Therefore, rho is equal to 1000 kg per meter cube into G value 9.81. Right. Finally, we have the pressure head at section 1-1 or upstream of the orifice. Therefore, P1 by W is equal to P1 divided by rho into G, 19.62 into 10 power 4 divided by 1000 into 9.81. This is equal to 20 centimeters. Okay. Now we are going to determine that this is the pressure head at section 11 or in the pipe. Then we are going to determine the pressure head at the orifice. P1 is given, that is equal to P0. Pressure at the orifice or downstream section, that is P2 or P2. Now we are going to take the P2. The pressure P2 is given, that is equal to 9.81 Newton per cm square. First this convert into 9.81 into 10 power 4 Newton per meter square. Based on this value, we are going to determine the pressure head. That is, pressure head at the downstream side of the orifice is equal to P2 by W or P2 by rho G, that is equal to P2 is given. P2 is nothing but 9.81 into 10 power 4 divided by rho is nothing but density of water, that is 1000 kg per meter cube into G is equal to 9.81. Finally, the value of this is equal to 10 meters. Right? We want to determine the H, the pressure head difference between the upstream side of the orifice and downstream side of the orifice. Therefore, pressure difference H is equal to P1 by W minus P2 by W, or P1 by rho G minus P2 by rho G. Right. Already we have determined P1 by W is equal to 20 centimeters, 20 meters. This is 20 meters. 20 meters minus 10 meters equal to 10 meters, or this is equal to 1000 centimeters. That the pressure head difference between the upstream side of the orifice and downstream side of the orifice is determined, that is 1000 centimeters. Now we are going to substitute the values in this equation. Finally, we have the flow discharge in the pipe, the rate of flow in the pipe. Right? Therefore, Q is equal to CD. CD is given, that is equal to 0.6 into A0. A0 is determined, that is the area of the orifice is equal to 78.54 into A2. A2 is determined here 314.16 divided by square root of A1 square. A1 square 314.16 square minus 78.54 into root 2 into G value 981 into H. H is determined here, that is equal to 1000 centimeters. Therefore, all are known parameters, only unknown is Q. Now the flow, the rate of flow through the pipe Q is equal to, right. Now the rate of flow Q is equal to 68,213 centimeter cube per second. Now this converts into liters per second, that is 68.213 liters per second. This is the rate of flow through the pipe. Now we are going to solve one more problem related to the orifice meter. Please note down the problem. An orifice meter with orifice diameter 15 centimeters. 15 centimeters is inserted in a pipe of 30 centimeters dia. Dia of the pipe is given, that is equal to 30 centimeters. 15 centimeters is inserted in a pipe of 30 centimeters dia. The pressure difference measured by a mercury oil differential manometer on the two sides of the orifice meter is given a reading of 50 centimeters of mercury. 50 centimeters of mercury, that means X is given, that is equal to 50 centimeters of Hg. 15 centimeters of mercury. Find the rate of flow of oil of specific gravity. What is the Q? Oil specific gravity is given, that is equal to 0.9. where the coefficient of discharge of orifice is that is CD value, coefficient of discharge of orifice is given, that is equal to 0.64. In this problem also we are going to determine the rate of flow discharge of the pipe, but here there is a orifice meter provided in the pipe. The pipe diameter is 30 centimeters. Here there is a provided one orifice. The orifice diameter is equal to 15 centimeters. And one more point, the provided upstream side and downstream side one manometer like this. Right, this is the upstream side, this is the downstream side, or this is section 1.1, this is section 2.2. Right? Here the manometer reading given, that is manometer reading is given, that is 50 centimeters of Hg. Manometer reading, this is the level difference. The level difference between the left side limb and right side limb. The diameter is more here at section 1.1. Automatically the pressure head is more. Here the pressure head is less. Therefore the manometer reading is given, that is 50 centimeters. Right. The discharge formula Q is equal to CD A0 A1 square, A0 A1 divided by square root of A1 square minus A0 square into root 2GH. But here we are going to determine, right, now we are going to determine the cross-sectional area at the orifice and cross-sectional area of the pipe. A0 is equal to pi d0 square by 4. This is equal to pi into dia or orifice opening is given, that is 15 centimeters. 15 square divided by 4. This is the cross-sectional area of the orifice. Cross-sectional area of the orifice. And A1 is the cross-sectional area of the pipe, that is equal to pi d1 square by 4, that is equal to pi into, what is the d1? Diameter of the pipe, that is 30 centimeters, so 30 square divided by 4. This is the cross-sectional area of the pipe, this is the cross-sectional area of the orifice. Right? A0 known to us, A1 known to us, CD value given, only unknown is H. G is equal to 981. Right? Only unknown is H, so that H is determined. What is the data given here? The manometer reading is given 50 centimeters of Hg. Now, the level difference, the pressure head difference between section 1.1 and section 2.2, or the pressure head difference between the pipe and the downstream of the orifice meter, or the pressure had the difference between the upstream side and downstream side of the orifice meter. That formula is H is equal to X into specific gravity of the heavy liquid minus specific gravity of the flowing liquid minus 1. Therefore, H is equal to X is given, that is equal to 50, and SM, specific gravity of the manometer liquid mercury, that is 13.6 divided by S0, specific gravity of the flowing liquid given, that is equal to 0.9 minus 1. Then finally we have the H, that is the head, pressure head difference between the upstream and downstream of the orifice meter, that is equal to 5.5 centimeters. Right? We know we have calculated H here, only unknown is H. Now we are going to substitute the all known values. So finally we have the discharge Q. Right, discharge Q is equal to CD is equal to 0.64 into 0.64 into pi into 15 square divided by 4 into pi into 30 square divided by 4 divided by square root of a1 square. This is a1 square. This is pi 30 square divided by 4 whole square. A1 square minus a0 square. A0 is nothing but pi into 15 square divided by 4 whole square into root 2981 into h already we have determined that is equal to 705.5. Right, finally the discharge Q is equal to CD A0 A1 divided by square root of A1 square minus A0 square into root 2GH. CD is equal to 0.64. A0 is the pi into 15 square by 4 whole square. No. A0, A2 is pi 30 square by 4. A1 square pi into 30 square by 4 square minus A0 square pi into 15 square by 4 whole square into root 2GH. Root 2G981 into H already determined, that is 705.5 centimeters. Finally the discharge from the pipe is determined here 137444 centimeter cube per second. Now this converts into liter per second, that is equal to 137.44 liters per second. This is the rate of flow through the pipe. Right, these are the problems related to the venturimeter and also orifice meter. Right, next class we are going to discuss about pitot tube. Right, thank you one and all. Okay, today we are going to discuss about problems related to pitot tube. Already I have explained pitot tube is the device which is used to measure the velocity of flow in pipes as well as in case of open channels. Right, now we are going to solve problems related to pitot tube. Please note down the problem. A pitostatic tube placed in a center of a 300 mm pipeline has one orifice pointing upstream and other perpendicular to it. The mean velocity in the pipe is 0.80 of the central velocity. Find the discharge through the pipe if the pressure difference between the two orifices is 60 mm of water. Take the coefficient of pitot tube is 0.98. Right, in this problem they have given diameter of the pipe that is equal to 300 mm and CV value given, coefficient of pitot tube is given, that is equal to 0.98 and mean velocity equal to 0.80 times the velocity of flow. This is the given data. By using this data, find the discharge through the pipe. What is the discharge? Q. In case of pitot tube, we know one formula for the determination of velocity. V is equal to actual velocity V equal to CV into root 2GH. I have derived this equation, velocity V is equal to CV into root 2GH. CV is given, that is equal to 0.98, coefficient of pitot tube, 2 value G equal to 9.81, H. If the pressure difference between the two orifices is 60 mm of water. In case of pitot tube, V is equal to velocity V is equal to Cv into root 2gh. Cv is given, coefficient of pitot tube 0.98, 2 value okay, G equal to 9.81, H is given, that H is equal to the head difference between two points is given, that is equal to 60 mm, that is equal to 0.6 meters. For the determination of Q, we should calculate the velocity V. Right? Velocity V is equal to Cv root 2gh. Cv is given 0.98 into square root of 2 into 9.81 into h is equal to 0.06 meters. Finally, the velocity of flow through the pipe equal to 1.063 meters per second. This is the velocity of flow through the pipe. But they have given one relation, that is the mean velocity is 0.8 times the velocity of the flow in the pipe. Therefore, mean velocity U bar equal to 0.8 times the velocity of the pipe. This is equal to 0.8 into velocity of flow determined here 1.063, mean velocity is equal to 0.850 meters per second. Now we have determined here the velocity, the mean velocity of flow in the pipe. Right? Now discharge Q is equal to we know one formula, that is equal to cross sectional area into velocity of flow or mean velocity of flow. Therefore, cross sectional area, diameter of the pipe is given, that is 300 mm, that is equal to 0.3 meters. Therefore, A is equal to pi d square by 4 into V. Therefore, pi into diameter of the pipe is 0.3 meters, 0.3 square divided by 4 into velocity of flow, that mean velocity is equal to 0.85. Finally, the discharge flowing through the pipe Q is equal to, from this equation, 0.06 meter cube per second. This is the rate of flow from the pipe. Right. Now we are going to solve one more problem related to the pitot tube. Please note down the problem. Find the velocity of flow of an oil through a pipe when the difference of mercury level in the differential U-tube manometer connected to the two tappings of the pitot tube is 100 mm. Difference of mercury level, that X is equal to 100 mm. Take the coefficient of pitot tube Cv equal to 0.98. This is the given data, and specific gravity of the oil given, and specific gravity of oil given, that is 0.8. From this equation, find the velocity of flow. V is equal to what? Based on the pitot tube theory, we know the velocity formula. Velocity V is equal to Cv root 2gh. Here coefficient of velocity is given, that is equal to 0.98, 2 into G value 9.81. H is not given directly. For the determination of the H, they have given manometer reading, that is manometer reading X is equal to 100 mm. Now for the determination of pressure difference, we know one formula, H is equal to X into specific gravity of the heavy liquid to the specific gravity of the flowing liquid, that is oil, minus 1. Now H is equal to, X is given 100 mm, that is equal to 0.1 meter, into specific gravity of the heavy liquid, that is the mercury, 13.6, specific gravity of the flowing liquid, that is given 0.8 minus 1. Therefore H is equal to 1.6 meters of oil. Once we know the H, the pressure difference between the two sections, now we are going to determine the velocity of flow through the pipe. V is equal to CV root 2GH. Now CV is equal to coefficient of pitot tube given, that is equal to 0.98 square root of 2 into G value 9.81 into H we have determined here, that is equal to 1.6 meters. Therefore velocity of flow through the pipe V is equal to, velocity of flow through the pipe V is equal to 5.4 meters per second. Right, these are the problems related to the pitot tube.